Hi, this is Mrs. Baisden, and today we're going to review how to write formulas. So the first thing we're going to look at and review a little bit are the different types of compounds that we talked about. So an ionic compound is a metal and a nonmetal, or a metal and a polyatomic ion. And again, a polyatomic ion is a group of atoms that are bonded together that act like an ion, or they behave as an ion. A covalent compound is a nonmetal and a nonmetal bonded together. A binary acid is hydrogen and an element, and then oxyacid is another type of acid where you have hydrogen and a polyatomic ion. But remember that if you have an acid, you always have hydrogen. Another quick review on the periodic table. When we write formulas for ionic compounds, we have to remember what the different charges for the groups are, and that has to do with how many electrons they gain or lose when they form compounds. So if you remember from before, everything in group 1 had a +1 charge. Group 2 had a +2 charge. We're going to skip over now to group 13, had a +3 charge. 14 we don't really worry about because a lot of stuff's going on in 14. Sometimes they share, sometimes they form compounds. Some at the bottom have multiple charges, so we're not going to worry about 14 for now. 15 has a -3 charge. 16 is a -2, 17 is a -1. 18 are noble gases, and those for the most part don't form compounds. Now when you get down here to the transition metals, a lot of the transition metals have multiple charges. They don't all have multiple charges, and you even have some multiple charge metals down in here, but you'll find a lot of the multiple charge metals in there. And again, what that means is they don't always have the same charge. So when you're dealing with the multiple charge metals, that's where you're going to see those Roman numerals that help specify which form of that particular ion it is. So we're going to go through the different groups of compounds and how to write the formulas for them. So we're going to start with ionic compounds. So for ionic compounds, you are going to crisscross the charges. So that's kind of our little shortcut method of making sure that the whole compound is balanced and all the charges balance out to 0. So by using the charges that we just looked at and crisscrossing them, that makes sure that that formula is and that compound is balanced. So like we said, the charges come from the periodic table, or the charges on the polyatomic ion if you're dealing with a polyatomic ion. So let's go through a couple examples here. So we have sodium oxide. So sodium is Na, and from that periodic table we just looked at, we know that's a +1 charge. Oxide comes from oxygen, and oxygen, if we look back, is a -2. So once you've done that, when we talk about crisscrossing, okay, sorry, I just lost my elements here. Is we're going to bring this down over here and this down over here. So then what that gives us is Na2O. And what I meant by making sure everything was balanced, what you can do then if you want, you don't necessarily need to because the crisscrossing won't take care of this, but to show you what that means, since sodium had a +1 charge and there's 2 +1 charges, that's an overall contribution of +2 from sodium. Oxygen, we said, had a -2 charge, and there's one of those. We don't write that one, but we know there's one there. That's a -2. So +2 -2 gives us that overall charge of 0. So by crisscrossing, we're taking care of making sure that that overall charge is balanced. Okay, let's look at our next example. Aluminum chloride. Aluminum is a +3. It's in group 13. Chloride comes from chlorine. That's a -1. So we go back, crisscross our charges here. We end up with AlCl3. Okay, our next example is one of those multiple charge metals that we just talked about. So when you have a Roman numeral, that belongs to the metal. So that Roman numeral 2 tells me that copper is a +2 charge. So copper here would be +2. Chloride again comes from chlorine. That's a -1, just like before. Crisscross those, and we get CuCl2. And then our last example shows how to deal with a polyatomic ion. So sodium, we know, is just Na, and we know that's a +1 from looking at our periodic table. Acetate is not an element on the periodic table. That's one of those groups of atoms that together are acting as an ion. So you have a sheet of polyatomic ions, and eventually you'll get very familiar with these if you don't remember them from before. But acetate is C2H3O2, and that whole thing has a charge of -1. So just like before, we're still going to crisscross these. So that -1 comes down there, plus 1 goes over there, and we end up with NaC2H3O2. Okay, the other thing about ionic compounds is that you can reduce those subscripts. So if, for example, we had copper sulfide, which would have ended up being Cu2S2, then those 2's, our final correct formula would just be CuS, because those 2's would cancel each other out. When you're dealing with the polyatomic ions, if you would have had a charge there, like on this sodium acetate, if this would have been magnesium acetate, magnesium's a +2, so C2H3O2, when you brought that 2 down, you would have to put parentheses around the polyatomic to show that this 2 goes to the whole thing. Okay, our next group that we're going to look at are covalent compounds. Covalent compounds are probably the easiest to deal with because all you have to do here is decode the prefixes. Now the prefixes we talked about before, and you have a list in your old notes or you have a list in your book if you want to look those up. But the prefixes tell us how many of the element are there. So our first example is carbon tetrachloride. So carbon, there's no prefix, that means there's just one of those. Tetra means 4, and that comes in front of chlorine, so that means there are 4 chlorines. So carbon tetrachloride is just CCl4. Our next one, dihydrogen monoxide, di means 2, so that means I have 2 hydrogens, and then oxide, monooxide or monoxide means 1O, so that would just be H2O. Last example, carbon dioxide, di means 2, carbon dioxide is just CO2. So those are pretty easy in comparison to the others. Our last class of compounds that we want to deal with are the acids. So acids start with H, so this is going to be hydrogen with an element or hydrogen with a polyatomic ion. So our first example is hydrochloric acid. So hydrochloric, if you see the hydro in front, that means it's a binary acid. That means there's only 2 elements. So that means you're going to have H and then whatever element is combined with it. So chloric, you're going to look at the root. That was chlorine, so that's HCl. Now that's still, you still need to worry about the charges. So you still have to go back and make sure that you look up and crisscross charges. Now most binary acids are just going to be 1 and 1 like that, but to give you an example of one that's not, if I have hydrosulfuric acid, so hydrosulfuric acid, hydrosulfuric still starts with an H, sulfuric comes from sulfur. So in this case, hydrogen is a +1, sulfur is a -2. So this binary acid has a formula of H2S. So not all binary acids are going to be a +1, -1. So you always want to go back and check those charges when you're doing that. Okay, our last 2 examples are sulfurous and sulfuric. If you remember from before, again, if a polyatomic ion ended in ITE, it became an US or OUS acid. If it ended in ATE, it became an ick acid. So if you remember, we said I ate acid, I feel icky. That's one way to remember it. So sulfurous acid came from a polyatomic that ends in ITE. Even though there's no hydro there, it's an acid, so it still has to start with H. So even though there's no hydro, these acids are still going to have H as the first element in that compound. The second part then, you're going to use the ending here to figure out what the polyatomic ion was. So if this becomes sulfurous, that means the polyatomic was sulfite. So sulfite, if you look on your chart, if you need to, is SO3. Again, we're going to look up our charges. H is a +1, sulfite is a -2. We're going to crisscross them. So this is H2SO3. Our last example is an IC acid. It's an acid, so it still starts with H, but ick, sulfuric, came from 8. So that means this would have been sulfate as the polyatomic it started out with. So sulfate is SO4. Still looking up the charges, H is a +1, sulfate is a -2, crisscrossing, so this ends up being H2SO4.